everybody, my name is Kate Berry from the University of Texas at Austin, and today I'm going to talk to you about change problems. Change problems are featured in all three of our Pirate Math Equation Quest interventions. We see change problems in our individual intervention with total difference and change problems, in our small group intervention with total difference, change, and equal groups problems, and in our third grade STAR test prep program with total difference, change, and equal groups problems. Today we're going to focus our attention on change problems. Our Pirate Math Equation Quest intervention has 5 components: Math Fact flashcards, Equation Quest, Buccaneer problems, ship shape sorting, and our Jolly Roger review. We see change problems featured during our Buccaneer problems, ship shape sorting, and our Jolly Roger review. We see change problems in our Buccaneer problems when students solve word problems according to schemas. We see change problems in our ship shape sorting when students identify word problems as belonging to a different problem type, such as total, difference, or change. And we see change problems in our Jolly Roger review, which is our independent practice, when students solve word problems. Primarily today, we're going to focus on the change problems that are featured in our Buccaneer problems because this is when we most likely see the change problems in our intervention. When we talk about change problems, you'll need 4 different materials. The Run poster, which is our word problem attack strategy poster, your change poster, Buccaneer problems worksheet, and a pencil. As students become more comfortable and advanced in solving word problems according to the different schemas, you may choose to fade out the posters. But for the purposes of these demonstrations in this video today, we're going to talk about and use these posters. We have 4 different types of word problems that we talk about: total, difference, change, and equal groups. Research validates using schemas or word problem types to teach students how to solve problems. Students first learn to identify the problem as belonging to one of these 4 different types, and then students develop a problem solution by following the specific schema steps. Today, students are going to follow the schema steps for change problems. For all 4 of our word problem schemas, total, difference, change, and equal groups, we teach students a gesture that corresponds with each schema. We find that attaching a gesture to the schema really helps improve students' recall. So for change problems, we teach students that we have a start amount that increases or decreases to a new amount. So we put our hand by our chin, move it up to our forehead to show an increase, and move it down here to our chest to show a decrease. Let me model again what the gesture looks like for change schemas. We have a start amount that increases or decreases to a new amount. As we go through our word problems today, we will use the change gesture. We introduce students to 4 different types of change problems. I'm going to demonstrate word problems where there's an end amount missing, a starting amount missing, a change amount missing, and I'm also going to demonstrate a double change problem. So let's first take a look at our change poster so we know what students will be following. Students follow and use this change poster to solve all 4 of the different change problem types. Here, our first step is to write ST plus or minus C is the same as E. ST stands for the start amount or the starting amount. C stands for the change amount, and E stands for the end amount. If the problem is a change increase, the student uses the plus sign in the equation. If the problem is a change decrease, the student uses the minus sign. On the slides that follow, I'll show you an example of a change increase and a change decrease problem so you can see when students might use the plus sign versus the minus sign. Step 2 that students follow for every change problem is to write ST. That stands for the start amount. So what number is our starting amount? Step 3 is to find C, the change amount. And step 4 is to find the number that corresponds with the end amount. Step 5 is write the signs. So we either have a plus sign or a minus sign. We use a plus sign if it's a change increase problem. We use a minus sign if it's a change decrease problem. And then we use our same as our equals sign. Then we solve for x. And lastly, we identify if the problem makes sense or not by talking about it out loud and using our gesture to see if our answer makes logical sense. So let's first take a look at a change problem where we're identifying that there is an increase. Let's read it. Susan had $5 in her piggy bank. Then she earned $7 for babysitting. How much money does Susan have now? Here we see that Susan started with an amount and then she earned more money. Because Susan is earning more money, her amount is increasing. We would call this a change increase problem. So the equation that we would use for this problem would be ST plus C is the same as E. Here we use the plus sign because this problem is showing a change increase. Now let's take a look at a change decrease problem. This problem says there were 9 oranges on the tree. Then 5 oranges fell off. How many oranges are on the tree now? We had some oranges, then some fell off. If oranges fell off the tree, our amount is decreasing. So we identify this as a change decrease problem. So for a change decrease problem, we would use the equation ST minus C is the same as E. So we teach students to do a change increase and a change decrease. On the slides that follow, we'll look at examples of both of them. First, I'm going to demonstrate a change problem where the end amount is missing. So let's take a look. This problem says, Frances poured 57 cups of lemonade. She sold 38 cups. How many cups does Frances have left? Whenever we see a word problem, we teach students to run through the problem, which is our word problem attack strategy. We first look to see if there is a table or a graph. There is not a table or a graph in this problem. If there were a table or a graph, then we would number it. But there's not, so we're going to run through the problem. So I'm going to write R, U, N to remind myself of the run steps. We've already read the problem, but let's read it again. Frances poured 57 cups of lemonade. She sold 38 cups. How many cups does Frances have left? We've read the problem. The U stands for underline the label and cross out irrelevant information. I look for the label in my question sentence, which is the sentence with the capital letter and the question mark. It says, how many cups does Frances have left? The question is asking me about cups, so I'm going to underline cups because cups is my label. Now I need to check for irrelevant information. I want to make sure that all of my numbers are talking about cups. So let's scan the problem. Our first number is 57. That's talking about cups, so we need that number. Our next number is 38. That's also talking about cups, so we need that number as well. We do not have any irrelevant information in this problem, so I'm going to check off the U. The N stands for name the problem type. When we name the problem type, we need to ask ourselves, are we putting parts together for a total? Are we comparing two amounts for a difference? Do we have a start amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Here, I see that there was a starting amount, then something happened to change that amount. Frances poured 57 cups, but then she sold 38 cups. We have a starting amount, and then she sold the cups. Something happened. She sold the cups, so our amount is decreasing. So I know this is a change problem, and this is a decrease. So I'm going to put a C and a minus right here. This lets me know that this is a change problem and that I'm talking about a decrease. She had an amount, but she sold some cups, so our amount decreased. Now I'm ready to follow my change poster steps. Step 1 says write the change equation. Here I'm going to use the change decrease equation because this problem is a change decrease. So I'm going to write ST, which stands for my starting amount, minus C, which stands for the change, is the same as the end amount. Step 2 says find ST. ST stands for the starting amount. Here it says Frances poured 57 cups of lemonade. That was the amount with which she started. So I'm going to put 57 I just said 56. 57 cups of lemonade. We've used that number, so we're going to check it off. Step 3 says find C. C is the change amount. She had 57 cups, but then she sold 38. That was the change that happened. So I'm going to put 38 under our C. And again, I'm going to check off the number as a reminder that I've already used it. Step 4 says find the E. We don't know the end amount. It says how many cups does she have left. We don't know the end amount, so we're going to put an X here. Step 5 says write the signs. Here again, it's a change decrease. I know I'm going to put a minus sign. I'm also going to look and make sure in my equation that my equation reflects the change decrease with the minus and same as sign. It does, so I'm going to follow that here. Step 6 is to find X. We find X by isolating the X. If you would like more of a tutorial on how to isolate the X and talking about isolating the variable, please reference our Equation Quest video. For now though, I'm going to draw a line down from the equal sign to remind me to balance both the sides. Let's circle the X. I see that X is isolated. X is alone on this side of the equal sign, so I can just subtract these two numbers. It's really difficult for students to subtract horizontally, so I'm going to rewrite my problem up and down. And I like to say I'm going to draw my line in between the 1s and 10s, and I'm going to circle my sign. Here I can't do 7 minus 8. I need to regroup or exchange or trade. So I'm going to cross out this 5 and make it a 4. And I'm going to exchange that 1 for 10 ones. Now I can subtract. 17 minus 8 is 9. 4 minus 3 is 1. X is the same as 19. But our number gets lonely when it's all by itself. It needs a label to keep it company. If I look in the problem, I see I've already underlined my label, which is cups. So I'm going to write cups here. I have my answer, my number answer, my label answer. Now I need to check to make sure it makes sense. For change problems, it's really difficult because sometimes we have an increase and sometimes we have a decrease. So we just kind of like to talk students through the problem. If we have 57 cups and we sold 38, then our end amount needs to be smaller or less than both of these numbers. Here we see our end amount of 19 is less than 57 and 38, so our answer makes sense. I'm going to take a second to erase the board, and then I'm going to show you an example of student work where a student solved a problem that's a change problem with the end amount missing. Now that we've demonstrated how to solve a change problem where the end amount is missing, let's take a look at student work. Here we see a problem. It says last year there were 11 trumpet players in the band. This year 14 new trumpet players, and we can't see the rest, but it must be irrelevant information, join the band. How many trumpet players are in the band now? So here we see the student cross out the irrelevant information because the question was not asking about trumpet players in that section of the sentence. Then the student correctly identified this as a change increase because we have trumpet players and 14 new trumpet players joined the band. We have an amount and it's increasing. So the student put a C to identify that it was a change problem and a plus to identify that there was an increase. Here the student wrote the equation ST plus C is the same as E, our change increase equation. The student identified the start amount as 11 because we started with 11 trumpet players. The student identified the change amount as 14 because we have 14 new trumpet players joining the band. The student identified the end amount as X because we don't know how many players are in the band now. Student correctly isolated the X, solved the problem. 25 trumpet players correctly put a number and a label. Because this is a change increase, our end amount needs to be the greater amount in order for our answer to make sense, and we see that's the case in this problem. Now let's take a look at a change problem where the starting amount is missing. Here we see a word problem. Whenever we see a word problem, we first have to check for a table or a graph. I do not see a table or a graph, so I can run through the problem. If I did see a table or a graph, I would number it first. But now I'm going to run through the problem. Again, run is the attack strategy we use when we teach students to solve every word problem. If you want more details on our run attack strategy, we have a separate video for that. The R stands for read the problem. Let's read our problem. Pam picked some apples at the orchard. She used 19 apples to bake apple pies and has 23 apples left. How many apples did Pam pick? So we've read our problem. The U stands for underline the label and cross out irrelevant information. I find my label in the sentence with the question. So let's read our question. It says, how many apples did Pam pick? The question is asking about apples, so I'm going to go ahead and underline apples as my label. But I'm not finished with the U. I now need to check for irrelevant information. We teach students to scan all of the numbers. If the numbers are not talking about apples, we know that they're irrelevant. Let's look. The first number we see is 19. We know that's about apples. We need that. Our next number, 23, also about apples. We need that. So we know we don't have any irrelevant information. Let's cross the U off. The N stands for name the problem type. We need to ask ourselves, are we putting parts together for a total? Are we comparing two amounts for a difference? Do we have a start amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Here, we have some apples. Then she used some apples to bake the pie. We have a change, decrease. She had an amount, there was a change that happened. What was the change? She used the apples to bake the pie. So I know this is a change, and our apples are decreasing. So I'm going to put a C minus in the corner over here. That's helping me identify that this is a change decrease problem. Now I'm ready to solve our change problem, and I can follow our poster. Because this is a change decrease problem, I'm going to start by writing our change decrease equation. ST minus C is the same as E. Now I'm going to find the starting amount. It says Pam picked some apples at the orchard. I don't know how many apples she picked. I don't know what the starting amount is, so I'm going to put an X under our ST. Step 3 is to find the C. I know that she used 19 apples for the pie, so that was the change. So I'm going to put 19 there. Now I need to do step 4, which is find E. The end amount is 23. She has 23 apples left. That's how many are at the end. So I'm going to put 23 here and check 23 off. One thing we like to tell students as a helpful reminder is if the question says some apples, that's a clue to us that that's missing information. Some could mean 20, some could mean 50, we don't know. But the word some is a clue to us that that's missing information. Here our missing information was under the start. Step 5 is to write the signs. In a change decrease problem, my signs are always minus and the same as. Step 6 is to find X. Again, we're going to find X by isolating the X. I draw a line down from my equal sign and I circle my X. X is not isolated or alone on this side of the equal sign. To get X alone, I need to move the 19. If it says minus 19, I can move the 19 by doing plus 19. And that cancels out. But what I do to one side of the equal sign, I have to do to the other side. If I plus 19 over there, I have to plus 19 over here. I'm going to draw my line in between my 1s and 10s, and I'm going to circle my sign. 9 plus 3 is 12, so I'm going to write a 2, and I'm going to bring my 1 over and add it to the 10s column. 2 plus 1 is 3, plus 1 is 4. My answer is 42. X is the same as 42. We always want to do X is the same as because we're always solving for X. That number is very lonely though. The number needs a label to keep it company. When I look at my problem, I see that I've underlined apples. So I'm going to write apples as my label. I have my number and my label. Now I need to check and make sure that my answer makes sense. If we have 42 and we use 19, does it make sense that we would have 23 left? Yes. When the start amount is missing, we tell students that the start amount is the greater number. Here, 42 is bigger than 19 and 42 is bigger than 23, so we know that our answer makes sense. Now I'm going to take a minute to erase our work, and then I'm going to show you an example of a student solving a change problem where the start amount was missing. Now that we've taken a look and demonstrated a change problem where the start is missing, let's take a look at student work. Here we see the student read the problem. Let's read it together. There were some students on the school bus. Then 19 more students got on the bus. There are now 34 students on the bus. How many students were on the bus to start with? We read the problem, we underline the label, which is students. Here we see 19 is about students and 34 is about students. We don't have any irrelevant information. The student correctly identified this as a change increase problem because we had some students on the bus, then something happened. What happened? More students joined the bus. So we know this is a change increase problem. So the student wrote our change increase equation, SC plus C is the same as E. The question asks how many were on the bus to start with. That's an indication that we don't know the starting amount. So the student put an X under ST. The change was that 19 more students got on the bus. So the change amount was 19. So the student wrote 19. And the end amount was 34 because that's how many are on the bus now. Then the student wrote the plus and same as sign, drew a line down, circled the X, realized that X is not isolated. If it says plus 19, we need to subtract 19 to get the X alone. If we subtract 19 from that side, we need to subtract 19 from this side. The student subtracted and correctly regrouped, exchanging 1 10 for 10 ones, and the student correctly wrote the answer as X is the same as 15 students. We know our answer makes sense because in a change increase problem, our end amount is always going to be the greatest number. Now that I've demonstrated a change problem where the end amount is missing and where the start amount is missing, let's take a look at a change problem where the change amount is missing. Here, whenever I see a word problem, again, I teach students to follow the attack strategy, run. Whenever we run, we first look to see if there's a table or a graph. Here, there is not a table or a graph. If there were a table or a graph, I would first number it. But there's not a table or a graph, so I'm going to run through the problem. So I'm going to write R, U, N. The R stands for read the problem. Let's read it together. In the morning, it rained 2 inches. Then in the afternoon, it rained some more. Over the whole day, it rained 5 inches. How many inches did it rain in the afternoon? I've read the problem. Next step is the U. The U stands for underline the label and cross out irrelevant information. I find the label in my question sentence. My question sentence has the capital letter and the question mark. It says, how many inches did it rain in the afternoon? The question is asking me about inches of rain. So I'm going to go ahead and underline inches. Now I need to check for irrelevant information. I need to make sure that all of my numbers are about my label. In this case, my label is inches, so I need to make sure that all of my numbers are about inches. Let's scan our problem and take a look. Here, my first number is 2. 2 is about inches. I need that number. My next number is 5. 5 is about inches. I also need that number. So I do not have any irrelevant information in this problem. My next step, the N, stands for name the problem type. I need to ask myself, am I putting parts together for a total? Am I comparing two amounts for a difference? Do I have a start amount that increases or decreases to a new amount? Or do I have groups with an equal number in each group? Here, we have a starting amount. It was raining, then something happened. What happened? It rained more. I know this is a change problem, and I know that it's raining more. That tells me that there's a change increase. So to remind me that this is a change increase problem, I'm going to put a C plus and circle it. Now I'm ready to follow the change steps. Because this is a change increase problem, in the morning it rained, then it rained more, I'm going to follow my change increase steps. My change increase equation is ST plus C is the same as E. Step 2 is find the start amount. In the morning, it rained 2 inches. I know that the starting amount was 2 because that's what it rained in the morning. So I'm going to put a 2 under the start amount, and then I'm going to check off my 2 here. Step 3 is find the change amount. It says, then in the afternoon it rained some more. Some more, we don't know how much some more is. Some could be 5 inches, some could be 10 inches. We are unsure. We don't know the change amount, so we're going to mark it out with an X. Our end amount is 5, because at the end of the day it had rained 5 inches. We started with 2, there was an increase. We don't know what the increase was, but at the end of the day it was 5. So I'm going to put a 5 there. I'm going to check that off. I've written my change increase equation. I've identified the start amount, the change amount, the end amount. Step 5 is to write the sides. I know from my identification here with a C+, that I'm going to use the change increase plus sign and same as sign. So let's add that here. Now step 6 is to find x. We teach students to find x by isolating the x. Let's draw a line down from the equal sign. Now we're going to circle the x. X is not alone by itself on this side of the equal sign. There is a 2 next to the x. To get rid of the x, it says plus 2, so I'm going to write minus 2. If I subtract 2 from that side, I also have to subtract 2 from this side. What is 5 minus 2? 5 minus 2 is 3. So what is my answer? X is the same as 3. But I don't just need a number answer, I also need a label answer. Label is inches, because that's what we underline in the question sentence. Now that we've shown and demonstrated how to solve a change problem where the change amount is missing, let's take a look at student work. In this problem, the student solved a change problem that was a change decrease where the change amount was missing. Here you see the student did an exceptional job by writing RUN in the corner. The student read the problem, underlined the label of cookies. Let's read it. Jack brought 78 cookies to school on his birthday. Then he gave some cookies to his friends. Now Jack has 23 cookies. How many cookies did Jack give away? We read the problem, underlined the label. All the numbers were talking about cookies, so there was no irrelevant information. Here, the student identified the problem type is a change decrease because Jack had some cookies, then he gave some away. So there was a change that happened. What was the change? He gave some cookies to his friends. If he's giving cookies away, there's a decrease. The student wrote the change decrease equation, identified the start amount as 78. The change amount is missing. He gave some cookies to his friends. We don't know how many cookies, so mark that with an X. The student identified 23 as the end amount because now he has 23 cookies at the end. Then the student isolated the X. Because there was a minus X, the student knew that he or she had to move this to the other side and put a plus X. And then the student rewrote the equation. 23 plus X is the same as 78. Subtracted 23 from both sides for a correct answer with a number and a label. I think the most fun change problems are our double change problems. So we've talked about change problems where the end amount is missing, change problems where the start amount is missing, change problems where the change amount is missing. So now let's work a double change problem. I'm going to show you what this looks like. Here we have a word problem. Whenever we see a word problem, we have to run through it. We first look to see if there's a table or a graph. We do not see a table or a graph. If we did see a table or a graph, we would number it. We do not, so we know we can run through the problem. So let's write our run steps right here. The first step in run is to read the problem. So let's read it. The problem says Pablo starts with 71 stamps. He buys 27 stamps from his friend. Then he then sells 56 stamps. What is the total number of stamps that Pablo has after the first day of the stamp show? So we read the problem. The U stands for underline the label and cross out irrelevant information. I'm going to find my label in the question sentence, which is the sentence that has the question mark and the capital letter. It says, what is the total number of stamps that Pablo has after the first day of the stamp show? The question is asking me about stamps. So I'm going to go ahead and underline stamps. Now I need to check and make sure that all of my numbers are talking about my label. I need to check for irrelevant information. We identified our label as stamps, so let's scan the numbers and make sure that everything is talking about stamps. Our first number, 71, that's about stamps. Our next number, 27, that's about stamps. And our next number, 56, that's about stamps. I know I don't have any irrelevant information. When we have double change problems, it's really important for students to understand that sometimes there may be extra numbers, and the students have to work really hard to determine if these extra numbers are identifying irrelevant information or if it's identifying more steps. Here we have 3 numbers instead of 2, but all of our numbers are talking about stamps, so we need all of them. Our next step in stands for name the problem type. I need to ask myself, am I putting parts together for a total? Am I comparing 2 amounts for a difference? Do I have a start amount that increases or decreases to a new amount? Or do I have groups with an equal number in each group? Here, I see Pablo started with some stamps, then he bought some more, but then he sold some more. So we have a change problem, but 2 things happen. This problem is different because we have 2 changes. He started with 71, and then he bought 27. If he bought 27, his number was increasing. But then a second thing happened. What was the second thing? He sold 56 stamps. So then our amount decreases. So we have a double change problem. We first have an increase when he bought the 27 stamps, and then we have a decrease when he sold the 56 stamps. So we are going to identify this as a double change problem by writing C plus minus. It's important for us to write the changes in order so that we can set up our equation correctly. The first change was an increase, so we first want to write a plus. The second change was a decrease, so then we want to write a minus. So now we're ready to follow our change poster. Here, step 1, all we have to do is add another space and another C to show our double change problem. So whereas before we wrote ST plus or minus C is the same as E, with a double change we write ST plus or minus C is the same as E. Let me show you what I mean. Here we have a change increase, then a change decrease. So we're going to write ST plus C, because we bought the stamps, then minus C, because we sold the stamps, is the same as E. So our double change equation for this problem is ST plus C minus C is the same as E. Now I can just continue to follow my change steps. Step 2 is find the start amount, or starting amount. Pablo, it says, starts with 71 stamps. So I'm going to put 71 under the start amount. I'm going to check off my number. Then we have to identify the 2 changes. It's really important for students to identify these in order so that we solve our problem correctly. We first have a change increase when Pablo buys stamps. He buys 27 stamps. That is the first change. So I'm going to put 27 under the first C. And I'm going to check off 27 to let me know I've already used that number. The next thing that happens is he sells the stamps. We have a change decrease. How many stamps does he sell? He sells 56. That's my second change, so I'm going to put that under the second C. I'm again going to cross off my number to let me know that I've already used that number. Then I need to find my end amount. The question is asking how many stamps he has at the end of the day, so I don't know the end amount. Step 5 is to write the signs. In this problem, I have a plus sign, a minus sign, and a same as sign, or an equal sign. So let's add those to our equation. Plus, minus, same as. Now when we solve for x, which is step 6, we're going to draw a line and circle the x. Here I see x is already isolated or by itself, so now I can just do the math. When we have more than 2 numbers, we always want students to solve left to right. So I like to make a little caret. I'm going to solve 71 plus 27. I'm going to write this problem vertically, draw my line and circle my sign, because sometimes it's really difficult to add horizontally. So here I'm going to start with my 1. 7 plus 1 is 8. And 7 plus 2 is 9. But I'm not finished. I still have to subtract this 56. So I'm going to write 98 minus 56. And then I'm going to write it over here. So I'm running out of room. So I'm going to write 98 minus 56 because I have brought this down. I'm going to draw my line, circle my sign. 8 minus 6 is 2. 9 minus 5 is 4. X is the same as 42. I have my number answer. And now I need my label answer, which is stamps, which is what I've underlined in the problem right here. Now the last thing I need to do is check to make sure my answer makes sense. When we have a double change problem, we just like to talk about it with students. So if we had 71
and we added 27, it would make sense that our number would increase, that we would have 98. And then if we subtracted 56, it would then make sense that we had 42. So our answer makes sense. Now, I'm going to take a second to erase the board, and then I'm going to show you an example of a student work where the student solved a double change problem. Here, this problem says, an art teacher had 736 crayons. She threw away 197 broken crayons, then she bought 150 more crayons. How many crayons does the art teacher have now? Here, the student read the problem, underlined the label as crayons. All three of our numbers are talking about crayons, so we don't have any irrelevant information. The student correctly identified this as a change, decrease then increase, because the art teacher had crayons, broke crayons, and then bought more. The student correctly wrote the equation ST minus C plus C is the same as E. Put our numbers in, 736, 197, 150. Isolated the X. Started with these first two numbers, subtracted, got this number, and then added our second change number for a total answer of 689 crayons. Now here's a video of a student working a change problem. And as you watch the video, I want you to be aware that the student is running through the problem, underlining the label, checking for relevant information, naming the problem type, and also going through all of our change steps, writing the correct change equation, writing the increase or decrease when it's appropriate, identifying the start, change, end amount, and then solving for X and writing our number and a label answer.
Okay, we're going to do B.
Okay.
You ready?
Mm-hmm.
What do you first check for?
A table or a graph.
Do you see one?
No.
But if you did see one, what would you do?
Number it.
Good, so what are we going to do?
First,
Run through it. Go ahead.
Mom put some jelly donuts on a plate. Then
Steve?
Steve brought 3 more donuts. How many? Now there are 18 donuts. How many donuts were on each plate first?
We're on the plate at first.
On the plate at first.
Good job. Okay, you read your problem. Now what's next?
Underline the label and cross out irrelevant information.
Excellent job. What's your label?
Donuts.
Good. Do you have any relevant information?
No,
Why not?
because all the numbers are talking about donuts.
Excellent job. Good. What's next?
Name the problem type.
What do you need to ask yourself?
Are we putting types together for total? Are we comparing two math letters? Or do you have starting math that increases or decreases steamer? Or do you have groups with an equal number in each group?
Excellent job. What kind of problem type do you think this is? You want me to read it again?
Change?
Good. Is it an increase or decrease?
Increase.
Why?
Because it says, because they had
some
donuts,
Mhm.
and they brought 3 more. Then Steve brought 3 donuts, and now they have 18.
Excellent job. What do you need to put in the corner before you write your equation?
C plus.
Good job. What's our start amount? It's a little tricky. We don't know it. Why not?
Because it says Mom put some donuts on the plate.
Right. Some could be 5. It could be 20. We don't know. So what are you going to put under the ST?
X.
Good job.
Then
Mm-hmm. Uh-oh. How's X?
he's mad.
He's just like really annoyed. Who's bothering him?
3
How are you going to get rid of it?
minus 3.
Draw your line, circle your sign. Good job. Nice job. You have your number and your label. Does your answer make sense?
Yes.
Let's talk about it. They have 15 to start with, then what happened?
They got 3 more donuts.
So does it make sense they would have 18?
Mhm.
Yeah, did you take some smart math pills last night? No, you're just a math genius.
Thank you so much for taking time to watch this video about change problems. I would like to take a moment to thank IES, the University of Texas at Austin, and the Meadows Center for Preventing Educational Risk. Without their support, this work would not be possible. Thank you so much.